Welcome back, guys. Let us consider our question, which is question number 4 on our analytical geometry. Given the diagram, we are given a circle having a center M, touches the x-axis at -1, 0, and the y-axis at B, which is 0, 1. So this is the condition of our circle that we are given. Touching the y-axis, which is here, the point of the x-axis, which is here at -1, 0, and the B, which is 0, 1. So we are given the one that has got a center at M. These are two things that you have to consider, all right? The circle, center M, this one that has got the center M, meaning to say we are talking about the bigger circle, all right? So then we talk about the smaller circle, a smaller circle centered at N. So the smaller circle, this one is having a center at N, even though it also passes through the point M, which is the center of the bigger circle. So N is the center of the smaller circle, okay? Then we are given that passes through M, so that is what you're given, and cuts the larger circle at B and C. So if you see, it is also having an intersection with the larger circle at B, which is the y-intercept, and at this point C. Then we are given B and C as the diameter of the smaller circle. That is B and C, we've got the diameter. So B is the end point of a diameter. C is also the end point of a diameter. And a tangent is drawn to the smaller circle at C and cuts the x-axis at D. So there is a tangent which is drawn from the smaller circle, this one, to cut the x-axis at point D. So this is a tangent. So it must also maintain the properties of a tangent. What are the properties of a tangent? Remember, a diameter or a radius, when it meets with a tangent, they do meet at what? At 90 degrees. So meaning to say at this point, we're going to have 90 degrees at C. These are the theorems that you're also supposed to put into consideration. Like I said, when answering, don't just limit yourself to analytical geometry, but extend yourself even to the Euclidean geometry as you're answering your questions. All right, so these are some of the properties that you were just given there. We do not know, maybe we might need that or not. So that's it. Question 4, 20 marks. Question 4.1, determine the equation of the circle centered at M in the form, this is the format that you're given, the circle centered at M, the one that has got M as the center. All right. So the circle that has got M as the center, this is what we have here. M is the center. So the question is, are we having the coordinates of that point M? Are we having the coordinates of the point M? So we do not have the point M in this case. We have to determine that. So this is 4.1. So from the point M, which is a point which lies on the circle, this is taken at the midpoint. Remember, it is going to be taken as this is the center. So from A, this is the midpoint. This is the end point of the circle. So from A to the point M, which is the center, the distance there is supposed to be the same distance from A to the point C. Talking of the radius concept. The same thing that we are having from the same point M to B, this is it, from the same point to B. What is it about this point M that we can conclude from what we are given? It follows that this is the A that we have, the X at point A, which is -1, 0 in this case, is the same as what we have at M. And the Y value at point B, which is 1, is the same. So this is going to be -1, 1. That is what we have there. So this is something that you're supposed to have put into consideration. This is at perpendicular. Remember the concept, a diameter subtends with what? Angle of 90 degrees. So the line, if this is at 90 degrees, the line taken from B, from M to B, the line taken from M to C, they are perpendicular to each other. So if they're perpendicular, it means CMA, this one is a vertical line. So throughout, if it is a vertical line, throughout, x is equal to -1, meaning to say also at C here, x is -1, even though we do not know the value of y, but there we must know that x is supposed to be a -1. So if we are to calculate the point C, or if we are to calculate the coordinates of C, and we do not have a -1, that means what I'm saying here is totally wrong. It's totally wrong. So this is the idea. So analyze that's the analysis of the diagram. That is where it is playing a role. All right. Anyways, that is it, guys. So we said M is the center of the bigger circle. And from this information, we just saw that this is going to be a vertical line. So throughout, X is going to be -1. And throughout the horizontal line MB, this one, throughout this line MB, this is a horizontal line parallel to the x-axis. So throughout, y is going to be 1 on that line. So this is the center. So we need the format, or that we are given the format also that we are supposed to have in the form of x minus a squared plus y minus b squared is equal to r squared, where this a and b is the center. So the AB part is there from our center. So we need the radius. So how do you calculate the radius? The radius is simply the distance that you are going to take from M to A, or from M to B, or from M to C. But by just mere looking on our diagram, guys, this is a horizontal line. So the distance here is simply from this point to this point is -1. So there's 1 unit. Or you can take it this one, the vertical line. This is the y-intercepted one. From this point to this point is 1 unit. So the radius of this circle is 1 unit throughout. The radius of the circle is 1 unit. So this is 1, this is 1, this is 1 throughout. This is just 1. Okay, so from here to here it's 1, from here to here it's 1. So our r there, which is our radius, is equal to 1 unit. So given our radius, or you can use the distance formula. If you do not understand what I'm saying here, you can simply use your distance formula to find the radius, since the radius is the distance that you take from R to B, from M to B, or from M to A. So you can use that R is equal to MA, which is equal to MB. So you can use the distance formula. Still, you're going to see that your radius was going to be a 1. All right. So let us substitute x minus the x value at our point, which is -1. So minus, that's a plus. Okay, plus y minus b, which is the y value there. So that is going to be r squared, which is radius squared. So 1 squared is a 1. So that is our equation in that format. That is what you're being asked today. So analyze your diagram, understand your diagram, calculate the coordinates of the point C. So C, where is it found if we are to consider this C that we are given? If we are to consider this, the point C is here. This is our point C here. There, what we need from the point C, it's actually clear, like if you understand like the distance concept. Because we said along this, guys, there are so many ways. You see, mathematics is something that is interesting. Working with maths, it's very, very interesting. Like you can play around the question the way that you want. All right, this is what is happening at C. C lies on AC, so it's a vertical line throughout. So I can just have the distance from A to C. The distance from A to C, it is, remember we said from A to M, it's 1 unit. From M to C, it's 1 unit. So it's 1 plus 1, which is 2 units. This is 0 here. It's from 0 here. So it means the C lies direct, the Y value at C, it corresponds direct at what? At 2. The Y value that we are having there at C, it corresponds direct at 2. So therefore, our point C is going to be taken. Remember, before we said it's already at what? At -1 from the vertical line concept. So C is -1, and the Y value there is what? The Y value is 2. Just like that. Or what can we do? We can use the midpoint concept, from which way, because we are given, so this is another way that you can use the midpoint concept. N is the midpoint of what? So N is the center, meaning to say N is the midpoint of a BC or CB. So if N is the midpoint, how do you calculate the midpoint? Let us go back to our formula sheet from the midpoint concept. The X value is added together divided by 2, Y value added together divided by 2. So it means we can use the same concept to say, let's say we do not know what is happening here. Let's say you do not know. You are going to take your point C as XY. All right. Let's say you do not know what we did here. You take your point C as XY and the point B is already given. Remember, we're talking about from B to C. So also the point B, which is 0, 1 like that. So the midpoint, how do you calculate the midpoint? You add the X values together. X plus 0 over 2 must be equal to the X value at the center at N, the midpoint. What is the X value there? That is minus half, minus 1 over 2. That's an equation. So you formulated an equation that you can solve, you can cross multiply. But like I say that if the denominators are the same, like what we see, there's a 2 there. The denominators are the same. So simply equate your numerators. If the denominators are the same, just equate the numerators together. It means X plus 0 is equal to what? Is equal to minus 1. So if X plus 0 is equal to minus 1, X is equal to what? Minus 1. Same thing, you do it on the Y values. Same concept about the midpoint. All right, that is the Y value at C. So that is going to be like this. The Y value at C plus the Y value at B, which is 1 over 2, is equal to the Y value at the midpoint at N at the center, which is 3 over 2. That's an equation. Yes, you can cross multiply. It's up to you, but these denominators are the same. There's a 2 there. Just equate the numerators together. So it means Y plus 1 is equal to what? 3. So Y is going to be equal to a transpose this 3 minus 1, that is going to be a 2. So just like that. So Y is equal to 2. So meaning to say, therefore, the point C given as XY can be written as minus 1 for the X value, then Y, which is a 2. So this is our point C. All right, let us just have it this way. So that's our point C there. Okay, so therefore the coordinate C is going to be given as minus 1, 2, which is to showcase that we could have calculated this in different ways. So it's up to you guys. The way that you calculate, just make it a way that you do not have it like you've done a lot of things, whereas theorems, ideas can be applied as long you are dealing or as long you are working with the geometry. You need to know the properties of the Cartesian plane, the properties of your lines, the properties of everything, all the angles, circles, and everything. Show that the equation of the tangent CD can be given as y minus x is equal to 3, and that's 4 marks for that. Equation of the tangent. Remember, truly, there is a tangent that we are given, CD that we talked about, that CD is a tangent. And what we need there is its equation. All right. So there we can consider to say, because there's a relationship, like I was saying, you're supposed to know your theorems. A tangent and a radius, they do meet at 90 degrees. That we know that. So if these two, they do meet at 90 degrees, we can take advantage of that. Because to have the equation of the tangent in this case, to have the equation of the tangent, which is CD or DC, we are going to need the gradient of that line. And also we are going to need a point which lies on that line. That is why they asked us to calculate the coordinates of the point C before, because we are going to need that point C to calculate the equation. So the point is there, but we do not have a gradient, all right? If you're given a point, guys, and a gradient, you can calculate the equation of a line. So what we need in this case is the gradient. The point is there. So the gradient now, that is the perpendicular part, is where it is going to play a role, that the tangent and the radius, or the diameter, the line BC, the line C to this point, whatever that you have there, they are perpendicular. So meaning to say that if CD is perpendicular to NB or to BC or to CN or whatever that you're going to consider the radius or the diameter. What does it mean? It simply means the gradient of CD multiplied to the gradient of the line BC should give us a -1. Remember the concept, when it is on the gradients, perpendicular lines, the product of their gradients is a -1. So what you're going to do is to use advantage of BC, because on BC, there we've got points. Either you consider it as B to C, B to N, whatever way that you want, because remember on the collinear concept, the gradient is the same along this line. So you can use B to N, you can use N to C, you can use B to C. You're going to have the same answer on your gradient. So there I'm just going to use B and C. So the gradient of BC from the change in Y over the change in X, that is B to C, the Y value at C, that is 2, minus the Y value at B, that is 1, over the X value at C, which is -1, minus the X value at B, that's a 0 there. So you can use that. You can even name your points from B to C. You can just call this X1, Y1, and C, this will be X2, Y2. That's Y2 minus Y1, X2 minus X1. So that was going to be the gradient of BC. So with the gradient of BC, because you are considering this to be the same throughout. So this was going to be 2 minus 1, which is 2, which is going to be a -1. So this was going to be -1. The gradient of BC is the same as the gradient from C to N. It is the same as the gradient from C to N, same as the gradient from C to B. So let me just write it here from the collinear concept. What I'm simply saying is that the gradient, this BC, this one that we calculated, the gradient of BC is equal to the gradient from C to N, which is equal to the gradient from N to B, the gradient from N to B or Bn. From which concept? The collinear concept. All right, same gradient. So choose whatever that you want, that you understand. Still, you're going to have the same thing. So now let us go back here to the calculation of the gradient of CD, because we need the equation of CD. So that's, we need its gradient. So the gradient of CD times the gradient of BC that we calculated, which is -1, should give us a -1 according to this formula. So what is the gradient of CD? Just divide by -1 both sides. This was going to cancel. So the gradient of CD is equal to what? A +1. With the gradient, we can calculate our equation. That is, we can determine our equation. Y is equal to mx plus c. That is the equation of a straight line. Or you can use, there are so many formats. You can use this format to determine the equation. Or you can use y is equal to mx plus c. So using y is equal to mx plus c, I have to substitute the gradient of DC, or the gradient of CD, which is 1. So that's 1 times x, which is x plus c. The y-intercept, now that's where we can take advantage of the point C. We only have a point, 1 point, which is C, which lies on what? On CD. We are talking about the equation of CD. On this line, there is only 1 point which is there. There is only 1 point there, which is the point C. And the point C is given as what? Point C is given as -1, 2. I mean, the point C, which lies on this what? On this line, not this one. This one is the value of C. There we need the point C. So using the point C, which is -1, 2, we're going to take the x and y value there. X and y values, that is 2 is equal to x, which is x -1 plus a c. Transpose the -1, that's a +2 plus 1, which is 3, that's a c. So therefore, our equation was going to be y is equal to x plus c, which is +3. But according to the format, what they just did was to transpose the x to the other side of the equation so that it becomes a negative. Y minus x is equal to 3. That's what they want you to show, but is one and the same thing as this part. So just show the way that you're given, they were done. So you're already given the equation. The equation was just show. just to show. So that is how questions might be given. That is how it is, or how it can be like. Number 3, we are given, determine the values of t. Okay, let's see what you're given. 4.4. Determine the values of t for which the line y is equal to x plus t will not touch or cut the smaller circle. Okay, y is equal to x plus, like if a line is written in the form of y is equal to, like what we are given in this case, this line is not supposed to touch or to cut the smaller circle. Okay. This line that we just calculated, this one, its equation, this tangent, remember we said a tangent. What a tangent does, it touches the circle like this. That's a tangent. And this is the one that we calculated its equation. Y is equal to x plus 3. This is the one. Y is equal to x plus 3. Remember that. So if this tangent here that we have, this one, the tangent that we have, this one, this is a tangent, and its equation is y is equal to x plus 3. That is the equation of the tangent. This one, that is the equation of the tangent. So the question is that if we are to maintain with the same gradient, the steepness is to maintain. The steepness is to maintain, because that is what they are saying. Y is equal to x plus t. X is still x as it is. The only thing that is supposed to be is a t. So they are saying for which values of this t that it will not touch the circle. It will touch the circle if our t, if this value is a 3. So what does it mean? It means for this, because there is supposed to be parallel, for it not to touch this circle, it means t is not supposed to be equal to this 3. T is not supposed to be equal to 3. Because when t is equal to, guys, please understand this. When t is equal to 3 like this, that is where you have this equation of the tangent as it is. When t is equal to 3. When this is at 3, this one. That's the y-intercept. So if the y-intercept still remains at 3, your line is going to cut there at 3, and it will remain as a tangent. But if this value changes, if it is now at 4, or maybe at another value which is not 3, it means it is no longer touching the circle. So it means our t is not supposed to be equal to 3. But that is not the case about this t. T is also affected because this line with a positive gradient, if you check, it is the same concept that is happening between from AB there. This line AB. This line AB is also parallel to that line that we are seeing there, because it has got the same gradient of 1. This line, it has got the same gradient of 1. The increase in y, remember the increase in y over the increase in x concept, plus 1 plus 1. There is a positive 1 in terms of the gradient there. There's a positive 1 in terms of the gradient. So it means this line also, it has a positive gradient y. A positive 1, like y is equal to positive 1, not just being positive, but exactly positive 1. And it passes through the y-intercept at B, so it is y is equal to x plus 1. So it means that if also we consider this, that this t is not going to be equal to 3, the same t is not supposed to be equal to 1. The same t, it is not supposed to be equal to 1, because if it is equal to 1, it is a tangent to the smaller circle. Look here, it's a tangent. It's a tangent to the smaller circle. So t is not supposed to be equal to 3, yes. T is not supposed to be equal to 1, yes. So what can we say about this t, which is not 3, which is not 1? So we can just conclude between these values from 3 to 1, t is not supposed to be any of these values. So meaning to say our t is not supposed to be 3, so our t is supposed to be a value greater than 1, but less than a 3. It is not supposed to be equal to this 3. It is not supposed to be equal, no. It is not supposed to be equal to 1. But also the t that we are talking about can be referred as a value that is less than 1. So t can also be a value which is totally less than 1. It can be a value which is also greater than 3. You can consider those values to say t can be within these values and also, but not to say it is equal to this. So if you check, this is removed to say it is not equal to 1. It is not equal to 1. It is not equal to 3. So there's no need for you to write it like this if you want. All right. So if you write it this way, it means you are limiting yourself to the solution. Say, so what is your solution then? You'll be limiting your solutions. All right. So that is what we had on this part. You were supposed to just consider your tangent concept, all right? The idea of a tangent that we had before, because a tangent, it is just touching the circle. So for it not to touch the circle, it means that value was supposed to only change. Every other property was not affected. 4.5, we are given that the smaller circle centered at N is transformed such that point C is translated along the tangent to D. Calculate the coordinates of E, the new center of the smaller circle. All right, let's be clear there. The smaller circle centered at N is transformed such that C, the point C is translated along, that is the most important part there, along the tangent, meaning to say, if something is transformed along, it is moving along that line. So N is going to move from where it is along the tangent. It is not going to change. It is going to move within the tangent to D. So take note, the center, such that this circle, this smaller circle that we have, which is centered at N, it has a point on it. Okay, let's look at the diagram. There's a point C there. Okay, this is our circle here. You understand me, guys? You understand here. Our P is gonna be clear. All right, I don't want to change this. Why is it changing what I don't want to change? All right, sorry for that, guys. See, these software, sometimes they can just tend to misbehave when you want to use them. But anyways, this is what the question is saying. There's a point C here. This is a point C here, which is on the smaller circle centered at N. So they're saying the point C is transformed along the tangent, along this line. It is being transformed along that line. That is what they're saying there. Along the tangent to D until it is at point D. So the point C that we are seeing here, this one, on the smaller circle, is like, it is our original point, this one. And D is the image, this one, because it has been transformed. So it is the image of what? Of C, which is at D. What are the coordinates of point D? Remember, D is the x-intercept of this line. Y is equal to x plus 3. Remember our line CD, we calculate the equation of that line. Y is equal to x plus 3 or y minus x. So you can consider that if y is equal to 0 in the x-axis, y is equal to 0. Remember that. So that means you can calculate the x-intercept transpose. This will be minus 3. So minus 3 is equal to x. So at the point D, x is minus 3. So that's minus 3, 0 there. So meaning we have to think of this to say, remember what happened at C, we had this, it was minus 1, 2. Remember that. So at point minus 1, 2 was transformed to minus 3, 0. This is what happened. A point is transformed from minus 1, 2 to minus 3, 0 along D. The question is not about this point, no. No, it's not about that. Let's answer the question. The question is, calculate the coordinates of E, the new center of the smaller circle. The coordinates of E, the new center of the smaller circle. So this is it. As the point, or as this line, as the point C was transformed to D, it follows that also the point N is going to be transformed along a certain line, but not along this line, but it's going to be transformed along a certain line. But what is it about this line that it is going to have from this C to the image? The line that it is going to be transformed, this line from the point N, which is our center, to the image point. If we are to consider, they are going to maintain some properties there, which is common. Which properties? Which properties are that? All right. One, this line that we are taking from the midpoint, which is C, to its image point, it is going to move the same distance, a transformation. So meaning to say, the distance that was moved from C to D, knowingly that CD is perpendicular to CB. So we are at 90 degrees there. And I am saying that we are going to move the same distance from the point N to the point of our image where we do not know the image point where it is, but we are going to move the same distance. And also seeing that there is a 90 degrees here that we are maintaining, and the line that we have drawn is maintaining same properties as this line. So what is it that is bringing you? What is it that you have there from your mind? These lines, they are parallel. They are maintaining same distance as they are moving from their objects, from the object here, from the original points to the images. They are going to move in a parallel manner. And in that manner, having same distance, what does it tell us about the origin, about the end points about this? It follows that if this is 90 and 90, also at the end here, whatever that we're going to have about C and D, because we've moved the same distance, they are going to be at 90 and 90. And what is it that we are formulating? This is a parallelogram. Whether it's a rectangle, remember a rectangle is a parallelogram that has got an interior angle of 90 degrees. So if a rectangle is a parallelogram that is being formed there, because you're forming a parallelogram, but a rectangle from these properties. So what can you use? Midpoint. Guys, know your properties. The moment that you just say, I have a parallelogram, know about the midpoint concept. The diagonals, they bisect each other. So meaning to say, I was going to calculate the image from N to the image which we are given called what? E, because that image we do not know, but we know that it's referred as E. Maybe E is at this point where given as XY. We are going to consider the midpoint concept there. From C to E, it's a diagonal there. From N to the point D, it's a diagonal. These diagonals that we have, they are going to bisect each other. Rectangle concept. The midpoint concept, the diagonals bisect each other of a parallelogram. So a rectangle, remember, it's a parallelogram. So it maintains same properties as a parallelogram. So that's we are done. So let us calculate our point E. So to find E in this case, to find E, you use the midpoint concept. So you're going to use the midpoint concept there. So what is it that you talk about the midpoint? we are going to have, we have got, okay, that is the line or the diagonal, in fact, all right? CE, which is CE, and N to D or DN. Okay, got same midpoint. So if they've got same midpoint, let's calculate that midpoint. Using the midpoint formula, the x values added together divided by 2, y values are added together divided by 2. So in this case, I'm going to use what is complete. So I'm going to use dn in this case. I'm going to use the line dn. Remember, at d, the x value is -3 plus at n, like I said, I'm going to use dn. At n, the x value there was -half. So this is -1/2 divided by 2. You do the same thing. The y value at d, remember d, that's a 0 there, plus the y value at n, which is 3/2. So that's 3/2, everything over 2. So this is our midpoint, which is the intersection of the diagonals. The diagonals, they intersect, they bisect each other for a parallelogram. And like I said, a rectangle is a parallelogram that has got an interior angle of 90 degrees. So this is what you're going to have as your midpoint, M and N. I mean, M, X, and Y values. So we can take advantage of the midpoint now and use this one, because we want to calculate the point E, the coordinate of the point E, remember? So you're simply saying, using the C part here, from C to N. So this time we're going to use Cn. What is the X value at C? At C there. The X value at C is -1 plus, because you just consider the average part, plus the X value, the X value at E, which is, remember, you're considering, I said CE. We want to calculate CE, not CN, CE. All right, so the X value at C is -1. The X value at E is the one that we want, over 2. So this is the mid value in terms of X, which is supposed to be equal to the X at the midpoint. Remember, this is our midpoint, this one. So the X at the midpoint is what? -7/4. That's an equation that you have formulated. Solve that equation to solve for X. So you're going to cross multiply this and that. It's up to you guys on this solving. 4 times -1, -4, 4 times X, 4X. So 4 multiplies everything. 4 multiplies everything in this bracket. 4 and -1, 4 and X. 2 times -7. 2 times -7, that is going to be a -14. So I can transpose the -4 to the other side so that it becomes a +4. So 4x will be equal to -14 plus a 4. So it will be a plus on this side. So that's -10. Divide by 4 by 4. That's obtaining the value of x, which is -5/2. So that's -5/2 there, the value of x. All right, seems like you have a lot of things there that you have to consider. All right, but there's so many ways. That's the advantage part of it. I'm gonna check also this question again, because this one is gonna take us a lot, but that's it. We're almost done. So we are going to do the same thing for the y values. We're gonna just do the same thing for the y value, considering our line CE. C, the y value at C, remember, let us consider at C here, the y value was a 2. So that's 2 plus the y value at E. So this is 2 plus the y value at, okay, still one and the same thing, over 2 is equal to the midpoint value at y, for y there, which is 3/4. Cross multiply this and that. You're going to solve for y just like the previous case. You were going to obtain -1/2. So therefore, our point E, because remember the point E is the one that we wrote there as xy. So therefore, our point E being the x value, -5/2, the y value being -1/2, like this. So the transformation, actually, we could have used, there are so many ways that we can actually use. I'm just gonna try by all means to bring those ideas of transformations bring them back from our grade 8, from our grade 9 there, so that you actually understand. But it's not that a matter of fact, but now I think, yeah, you can just play around with that information. Any other way, let us communicate so that we can even use that in our next class if you see that there's another way that we could have just used there. On question 4.6, we are given, if it is given that the area of the quadrilateral OBCD is 2a square units, all right, and a is greater than 0, show that a is equal to the square root of 7 over 2 units, the area of the quadrilateral OBCD. Okay, we need to show that a is equal to the square root of 7 units. So it means we must have somehow that quadrilateral. Okay, let's go to the quadrilateral. Let's check. OBCD. This is where we have it. OBCD. I'm just gonna... Okay, let's just hope there are some of other things, they are not gonna affect us, but I hope we are together. The OB. So it's actually like this. This is from O, remember, to B, to C, and to D. So it's like this. Okay. So it's like this, actually. This is what a shape that we are forming, sort of. All right. So I want you to consider this shape to say, if I had to work it from this point, let's say, let me just remove this part because this one is just gonna affect us for nothing here. Sorry guys, I just hope this software is not gonna stop because I need to finish this question. You see, these softwares, they can just tend to misbehave. All right, so I'm just hoping we'll be able to finish here because you see what my software is doing now, guys. All right, so this is it. I just gonna try and explain this. Let's hope you understand me, what we're supposed to do on this last part. So we are given that this is the quadrilateral or BCD. All right, that's 4.6. So if you were to consider that you're given the area on that case, and this is our quadrilateral, this quadrilateral is made up of A, if you were to consider, if we can remove this part of ACD, all right, which is the triangle and the trapezium part that I wanted you to see. Now everything has been removed, but still it's one and the same. Remember I said this line is a vertical line and we agree that it is at 90 degrees, where we say throughout it's -1, if you still remember. So meaning to say from A to C to D, this one, it's a right angled triangle, this one. So we can calculate the area of this triangle. Remember, C is at 2 units. So we have also the length of this from C to the point A is 2 units, okay? D is -3, where A is at -1. So -1 minus -3, it means there's a difference of 2 units also there. So we have got this distance, all right? From A to O, that is -1. So meaning that there's 1 unit there. From A to O, it's 1 unit. From O to B, it's 1 unit. So everything is just complete. There are 2 shapes that we are going to just separate. A trapezium, this one. A trapezium, remember a trapezium, we consider the parallel sides. So meaning OCD, the area that we are given there, we are given it, remember we're given that area in terms of A, but as we need to calculate the same area of O, B, C, D in terms as the numerical value. So it is a combination of 2 things. It is a combination of this triangle. So area of this is equal to area triangle. So you're going to calculate the area of triangle DAC, area triangle DAC, plus the area of this trapezium. you consider also the trapezium there. So there we're going to need the numerical value. So you need the area, trapezium, the area of the trapezium, OBCA. So OBCA. So by having this, we've got the area of the whole quadrilateral. Which shape is that? We do not even know that shape. So that is why we have to separate these figures, all right? So area of triangle DAC from D to A to C, half base times the perpendicular height is half of the base from D to A, which is 2, times the perpendicular height from D to C, which is 2. So this is our area. Remember, the area of the trapezium, half sum of parallel sides times the perpendicular height. So it is half sum of the parallel sides, these sides which are parallel. So it's actually half sum of parallel sides times the perpendicular height. So the sides which are parallel is the 2, which is the CA, which is 2 units, and the BO, so it was supposed to be half of CA plus BO times the perpendicular height, which is OA. So that was it. So this is half of 2 plus this point to this point is 1 times the height from this point to this point, from A to O, it's 1 unit. Remember, we labeled everything before. So you were going to calculate the area of the triangle, half of this times this, which is 2, plus you also calculate the area of this other side. That was going to give us 3 over 2 or 1,5. All right, then we add 2 plus 1,5, which is 3,5 square units. So this is our area, which is a numerical value. There we obtained, so this is just short for square units. We obtained the area there as a numerical value. But before, we were given this same area here as what? We are given a presentation of an expression to say the area of this quadrilateral is 2a squared. And a is greater than 0. So show that a is equal to this. All right. So if we are given that the area before in terms of a is 2a square units, the same area that we calculated here, the same area that we calculated as a numerical value in terms of a, in terms of what? Of a, it is equal to 2a squared. That is what you're given. So if these two, they're the same, the area there we calculated as a numerical value, there we are given it in terms of a. So simply we are going to equate 2a squared, our area, which is the expression part, is equal to the numerical value that we are given, which is 3,5. So what is the value of a? That is the question. So just simply divide by 2. So a squared was going to give us 7 over 4. Then we can determine our a, introduce the square root. There is no way that these two areas will be different. They will be the same. So that's why we are equating what is in terms of a to the numerical value. So a being the square root of any number plus or minus, that was going to give us plus or minus the square root of 7 over 2. We do not know the square root of 7, but we know the square root of 4 is going to be a 2. But we are told before that this a that we are talking about is greater than a 0. A is greater than. That's why we are given that condition, because there are 2 possible values. So therefore our a is the one greater than 0, means positive values. So that's the square root of 7 over what? Over 2. So that is the one that we are going to take since a is greater than what? Since a is greater than 0. So these are your typical questions. These are your typical questions, exam questions. They need you to figure out from the shapes that you're given, properties of your shapes also. Are you able to figure out this? If so, then let it be like that. So these are the typical questions that we have. More questions of this nature from Meson African motifs till we meet again.